We're solving problem 16 from the 2020 F equals MA exam A. Liquid droplets store a given amount of potential energy per unit surface area due to their surface tension. When two identical nearly spherical liquid droplets coalesce on a certain type of surface, part of this energy can be converted into upward kinetic energy, causing the coalesced droplet to jump. Assuming the conversion is 100% efficient, how does the maximum height h depend on the radius of r of the initial droplets? So here we have two droplets of radius r, and they form a big one of radius r prime. We know that volume is proportional to r cubed, therefore 2r cubed, which is the sum of these two droplets, is equal to the big one, or r prime cubed. So we have that. Then it goes to show that r prime is proportional to r. We can also say, due to this fact, and that u is proportional to r squared, we get that change in u is proportional to r squared. So we have those. And now what is change in u? Delta u is now, well, it's mgh. But since we find that mass is proportional to radius cubed, then we plug all these in, and then the above equation becomes r cubed is proportional to r squared h. So therefore, h is proportional to 1 over r. And this is going to be your answer for this problem.